Hello everyone, welcome back to the channel. Right now we are doing revision course for UPSC CSAT 2024 and we have started with the topic Algebra. In the last two videos we have already covered progressions and equations. In progressions we have seen arithmetic progression, geometric and harmonic, and in equations we have learned about linear, quadratic and cubic. So we are left with three subtopics in algebra which we are going to cover in this video, and this will complete our algebra after this. So, in only three videos of total around 1.5 hours, you would have revised and covered all the topics of algebra for CSAT 2024. So, it's helpful for everyone, even for those who have already covered through the videos. This is a revision for them and for the newcomers as well who are watching it for the first time. So, let's start with the today's topic. So, today we are going to do three topics, and the first one is logarithm function. So, what exactly is a logarithm function? So before understanding what exactly is logarithm function, we first understand what function is. A function is a machine which takes in some input and gives you some output, right? So suppose the machine x square is also a function. So whenever you are giving input as x is equal to 2, what are you expecting coming out of this machine? You are expecting that 4 will come out of this machine because 2 square is 4. So a machine is an function is a machine which converts input to an output. I hope it is clear. Now logarithm, log is also similar function. Log is written like this, log of x. So we input some x and you can expect some value y as the output, right? So now how do we write log? Log is written as y is equal to log of x with some base m. This base m we'll learn later. But for now, let's suppose this is a logarithm function y is equal to log of x base m. So, what exactly is logarithm function? We have learned about x square, y square, sine theta, cos theta. Those all are functions. But where does this logarithm come from? So, to understand logarithm, we need to understand exponent first. Exponent is nothing but whenever you do, suppose y is equal to 2 raised to power 2. So, this is an exponent. Exponent means raised to power. So this is an exponent. So from exponent, you can convert this exponent into a logarithm. How we will see now, right? So I'm just removing this part as well for the space. So suppose this is given to you, a is equal to b raised to power c. Is it an exponent? Yes. Why exponent? Because raised to power of something, right? So this is an exponent function, or you can say this is an exponent. We are going to convert into log. First thing, to convert into log, you put apply log function on both sides, left and right. So log of b raised to power c. So the first property we are going to learn today is whenever we have something raised to power and that is in a log, you can bring that in the front. So this will become c dot log of b. So that exponent or the raised to power can come in the front. So the first step is log of a is equal to c log of b. Please remember this property that whatever is in the power in the log, that can come in the front. So first part is done. Second part. The second property which we need to know, and don't worry, I will again rephrase them in the next slide when we are going to learn about the logarithm properties. And in logarithm, actually, you only need to learn all the properties by heart. There are like 7 to 8 which are of relevance to you. You need to learn all those properties, and that is those properties are going to be used when you are solving the logarithm questions, right? So those properties are very important. First one is done. Second logarithm property says whenever we have a number, say logarithm of m, and the base is same, means m and with has the same base, this is going to give you an output as 1, right? So some number with the base same as a base, you can they say the output is 1. So here what I'm going to do, I'm going to put this, I will say this log as a base of b. So whenever you decide the base, that applies for all the logarithms. So if I say that there is a log of b here, base b here, you all the logs which are in the equation, you have to use the same base. So log of A with the base B is equal to C dot log B base B, right? The next step is, this will remain the same, log of BA is equal to C dot 1 is equal to C. So C is equal to log of BA. Now you understand how we came from exponent to logarithm? Don't worry about the steps, you just need to know how the exponent and logarithm are related to each other. Don't remember this formula, just for your understanding, these are the two things, right? I hope this thing is clear. Now moving on to the properties, which is the main part in this, you have to learn all the properties. There is no shortcut to this. Learn the properties. Obviously, if there is a logarithm question comes, you need to know the properties of logarithm, right? So let's start. These are 6 properties. 7th property I am going to write here, which you have already learned. Log of A with the base B. Suppose even I say sorry, we say some has a base, any base. So that B could come in the front, B dot A. I hope this is clear. B dot A, that B could come here. And the second property which we already covered is log of some number with the base same is equal to 1. These two properties are the same. I hope you understand. Now moving on to the third property, or the first property which I have written here, log of A into B or log of M into N. So this is, just note it down, log of M plus log of N. Means whenever the log of M into N is given to you, then you can separate them as log of M plus log of N. This is clear? Whenever there is a division, log of M divided by N. So you can write it as log of M minus log of N. Please note it down. Log of M minus log of N. Wherever is this a division here. Third thing, log of 1. There is only one number is in the entire universe, log of 1. Whenever log of 1 is given to you, whatever is the base, no matter, you can say that is 0. So this is 0. This is the third property. Log of 1 is always 0. Log of 2, we don't know, but log of 1 is always 0. Now, third property, log of m raised to power n. This is the same property as this. So, I can say log of m raised to power n is n into log of m. This is what we have already learned, right? Fifth property I am writing here. Minus of log a. Can I write it like this? Log of a raised to power minus 1. Using the property number 4, where the power could come in the front and it also could go back. So this is equal to log of 1 by a. Any problem? No. So this is log of 1 by a. Fifth property is done. Now let's learn about the sixth property, that is log of base b a. You can write it like this, log of a divided by log of b. Log of a divided by log of b with any base you want, new base you want. So log of a base b could be written as log of a divided by log of b with some other base. So there are total of 6 plus 1, 7 properties, right? So I will mark it then. This is 1, 2, 3, 4, 5, 6. This will be the 7th property. This will be the property number 7. And this is also already repeated property number 4. So the first property is log of m into n. So log of m plus log of n. Second is m divided by n. Third is logarithm of 1 is always 0. Fourth property is raised to power m raised to power n is, you can bring n in the front. Fifth property is minus log a is equal to log 1 by a. This is just an application of property number 4. Property number 6 is log of a base b is log of a divided by log of b. Seventh property is log of m means log of some number with the base m is equal to 1. You can also see that here, if instead of m in here I have said that log of a divided by log of b. So since I have said you can choose any base, if I have chosen the base b in both, this will be log of a base b divided by 1. This and this are actually the same. This is just to prove that this is true. So log of m with the same base m is equal to 1. Right? Now let's understand and try to solve some questions on this. And again, you just have to reach there are always difficulty on how well you need to be prepared for a topic. Let's say one is easy, one is medium, and one is expert in the topic. You only need to reach till medium level in this logarithm topic. Not they cannot ask you a lot of difficult questions from this topic. Just the application of these properties. But if they have asked any difficult question, don't worry. 99% of the students are not able to solve that question. You are not alone. So okay, only reach till the medium level in this specific topic logarithm, right? So let's see. Log of 232. So 32 I could write as 16 into 2. Just I'm going to show you how I'm thinking. So this I can write as 4 into 2, 4 into 4 into 2. This I could write as 2 into 2, 2 into 2 and 2, or 32 is 2 raised to power 5. So log of 2, 2 raised to power 5 is 32. Can I bring 5 in the front by the property? So log of 2, 2. What is this? Any number with the same base is 1. So 5 into 1. So the answer is 5. I hope you understand how to solve logarithm questions. Easy. Moving on. This question. How will you solve this? Log of x is equal to log of 20 plus log of 2.5. Tell me what is the value of x. So the value of x is, again you are going to use the property of a into b. So log of a into b is log of a plus log of b. So 20 into 2.5. 20 into 2.5 is equal to log of 20 plus log of 2.5. So if I solve this, this is log of 50. Log of x is equal to log of 50. So x should be equal to 50. Simple. Second question is also solved of logarithm. Easy. Just the application of logarithm formulas. Third thing. Log of 27 into log of 1 by 243 base 27. How are you going to solve it? First thing. 243. This is my thinking. How will I think? This is 81 into 3, or 9 into 9 into 3, or 3 into 3, 3 into 3 into 3. This is 3 raised to power 5. This is clear. No worries there. So first thing I am going to do, even before that, is log of 27, 1 by 243 is 243 raised to power minus 1. Or I could write it as minus of log 27, 243. Right? Now, since I already know that I cannot make 243 with some 27 raised to power something. So what I need to do, I will write it like this. Log of 27, log of 243 divided by log of 27. Is this not the last property? If I go back, this property I am talking about, property number 6. So log of a base b is equal to log of a divided by log of b with similar base. So the base I am choosing is 3. Why? We'll see. This is clear? This step is clear? Now minus of log 3. 243 is 3 raised to power 5. And log of 27. Log of 27 is 3 raised to power 3. 9 3 are 27. So I hope it is clear. So I am just removing this part. If I remove this part from here, on in numerator I could get 5 into log of 3 3 and 3 into log of 3 3. This is 1. We know, and this is also 1. So this is minus 5 by 3 answer. I hope this is clear. We are just applying the logarithm, and you have to be very smart how to catch the logarithm topics. Only these 7 properties you need to know, and just after that the application matters. You know the property, how to apply it smartly is your trick. Now the logarithm topic is done. There we learned what is logarithm, and also we have learned 7 properties of logarithm. That's all you need to know. Moving on to the next topic, and the second last topic in algebra, that is set theory. What exactly is a set? Set is nothing but a well-defined collection of objects. Well-defined collection of objects. What is well-defined? Means they have some meaning. That collection has some meaning. Suppose I say set of Mumbai 11 players. There's a team Mumbai 11 in IPL. So the set. So you will say Rohit Sharma, Ishan Kishan, Hardik Pandya, some, and then you have Bumrah, and so on. This forms a set of all the players of Mumbai Indians, and this collection of all the players of Mumbai Indians forms a set. Anything which has a meaningful collection of objects is a set. First part is clear. You just understand the basic, and that's all you need. In later stage, we are going to solve difficult questions on this. So just the definition is sufficient for now. Another example is set of all the natural numbers. So this, suppose I say this is set number A. A is set of all the numbers. So how you write the set A? This is curly brackets. This is how you define the set. A, all the natural numbers are 1, 2, 3, 4, 5 till infinity. This forms us another set. It is a meaningful set of all the natural numbers. Set of integers. Yes, this is another meaningful set. B is equal to minus dot 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 minus 3, minus 2, minus 1, 0, 1, 2, 3 up to infinity. So this is another set. Infinite set. There are infinite numbers of objects in this set. So these are the three examples of sets. I hope sets are clear. Just the basic definition is sufficient. Now we are going to learn about the different terms in set theory. And what are we going to use the example of? We are going to use the example of sets. Oh, sorry, IPL, because IPL is going on right now, and it will be easy for most of the people to understand. Right? What exactly is a Venn diagram? I hope you have seen this, something like this Venn diagram. This or this, something like this. This. So what exactly is a Venn diagram? Venn diagram is just a pictorial representation of sets. So sets, you write it like a curly bracket 1, 2, 3, 4. So if you are using uh, pictorial form, that is a Venn diagram. First thing is universal set. So universal set is, suppose this is all the players playing in IPL. All the players, no matter the team, all the players that are playing in IPL forms a universal set. Universe means universe of everything, all the players. In this universe, there is a team that is Mumbai Indians, and this is all the players of Mumbai Indians. And there is another circle you could make, and this is Chennai, right? There's another team here that is RCB. Means this is a universal set of all the players playing in IPL, and these blocks form, these circles shows which all players are on which team, right? This is a universal set. Universal set means all the possible objects that could be exist in the universe, and universe of IPL in our example, and in that one circle represent a single set of a team. Union of two sets. So union of two sets, how could you represent union of two sets in an IPL example? Suppose, I'm not sure how we are going to do it, but suppose there is a player, we are taking example of all the IPLs before, right? So there is a player, suppose say Hardik Pandya, which has played in two teams, which are played in two teams, right? Two teams means he has played already, also played in GT, Gujarat, and he's also played in Mumbai. So this is the union of two sets. Union of two sets means this part represent that people who have played for both the teams now or in past. This shows that all the players of who have played for Mumbai only, and this part shows people who have only played for Gujarat. When we collect all the players in these three sections, means section number 1, section number 2, section number 3. When we consider all the players in this area, means this area, this area, this is union of two sets, means two sets are unionized or combined, right? So this is another union of two sets. I hope this is clear. So this part is clear, means union of two sets. Now the third part is, I'm removing this. Third part is difference. Again, we are taking the example of Mumbai Indians and Gujarat Titans. This is a universal set. This is a universal set. Here we have two teams, Mumbai Indians and Gujarat Titans. This represent who have played for both the teams, right? Now difference means set A minus B, means player who have played for Mumbai Indians, but they have never played for Gujarat Titans, means This part, which I have highlighted in yellow, will not be considered when we are thinking about the difference. Means all the players of Mumbai Indians minus those players who have also played for Gujarat Titans. Only this section, only this section. Mean this is A minus B. Means people who have played for Mumbai Indians but have not played for Gujarat Titans. Means that not the common area. That is difference of two sets. This is done. I hope this the definition is coming to you. This now moving on. Next part. Complement of a set. This is a complete IPL universe, and this is Mumbai Indians only. So this represent all the players of Mumbai Indians. So complement of Mumbai Indians will be people who have not are not playing for Mumbai Indians. Means complement of this Mumbai Indians is this white section. Means people who are not part of Mumbai Indians. This is the complement of a set. It is represented like this: A bar. A bar means who are not in the set. I hope it is clear. Moving on. Suppose disjoint set. Again, taking another example. Suppose there are two teams. I'm not going into the history. Suppose there are two teams right now. Right now, let's only consider IPL 24. This represent Mumbai Indians and this represent Chennai Super Kings. Can there be a common player which is right now playing right now in this season for both the teams? Is it possible that he's also playing for Mumbai Indians in this season? And whenever there is a Chennai match, he goes to the Chennai team and play in their matches. No. So these two sets are not joined together. These sets are not joined together. Suppose so. Whenever we are only thinking about this season, means one season of IPL, there cannot be any player which can be part of one team as well as part of another team. Whenever we looking at the Union example, we considered past season of IPLs as well. Means not only this season, because Hardik Pandya could not play for Mumbai Indians and Gujarat Titans in the same season. So that is why we have to go back in the history, and that is when we form that union set. Means Hardik Pandya has played for Gujarat Titans and Mumbai Indians. So this common section came by because we did not only consider this season but also the past seasons. So all these terms are hopefully clear. Venn diagram is this pictorial representation. Universal set is all the players of IPL. Union of set is when we were thinking about Mumbai Indians and Gujarat Titans, we made a two overlapping circles. So that is a union of sets. Difference of set is whenever difference set means a player has played for Mumbai Indians only and has never played for Gujarat Titans in the history. This part, right? Complement of a set is which is not part of a set A, and disjoint set means this example that right now no player could be part of two teams. That is why all the sets are disjoint to each other. They are not joined. Moving on to the next part. A union B. A union B means suppose this is a Venn diagram. This is a Venn diagram, and this part. If I ask you A people who are part of A or B, I don't care if they are part of both. Give me all the players which are part of either A or B. Either A or B. So whenever say union, this is a union. This whole region means all the players which are in this union of two sets. So A union B is this red portion. A intersection B is the second term is A intersection B. This circle, and where they intersect means this common area. This is A intersection B. This part is A intersection B. I hope it is clear. Now this is done. I hope A union B and A union B and A intersection B. Whenever say either A or B, in case of intersection, we say it has to exist in A as well as B. A and B. So there is and here and there is or here in the case of union, right? In set theory, you need to know one formula only, and that is this one, that A union B is equal to set A of all the members of set A plus all the members of set B minus A intersection B. I'm not going to go into the proof of this formula. Just let's see this Venn diagram and understand. A union B means this red portion, you could find the value of A union B. That will be equal to all the members in A, all the members in B minus A intersection B. This is the formula for A union B. I hope it is clear. Set theory formula, very important for the questions. Just please note it down. A union B is A plus B minus A intersection B. Now this part is also done. Moving on. This question is a set theory question. How many even integers n? First thing is they are asking for the even integers. Even integers n which are divisible neither by 7 or 9 between 100 and 200. So between 100 and 200 all the numbers are considered. Tell me which are the even integers. We have to find only even integers which are neither divisible by 7 nor by 9. So let's start with thinking about between, let's start with this, between 100 to 200, find all the numbers which are divisible by 7, find all the numbers which are divisible by 9, and these numbers have to be odd. So if we are able to find all the numbers which are divisible by 7, all the numbers which are divisible by 9, and also these numbers has to be odd. If we remove all these from 100 to 200 means 101 are total numbers. If we minus subtract these numbers, suppose numbers x, so you whatever you will get in the result y will be all the integers, right? Sorry. Let's remove odd part for now. We'll consider that later. For now, just imagine I only considering numbers which are divisible by 7 or 9, right? Between 100 and 200. So all those numbers between 100 and 200 means total 101 numbers. If we subtract all these numbers which are divisible by 7 or 9, you will get all the numbers which are divisible by, not divisible by 7 or 9, right? So this even integers is another complexity. You can do it in your homework part. I'm just keeping it for you, how you are going to use this, how you are going to separate even integers as well. For now, I'm only focusing on numbers which are divisible by 7 or 9. I will remove those numbers from my list of 101 numbers. Whatever is remaining, that is my answer. So let's see. So let's say suppose set of A which are divisible by 7. Divisible by 7. So whenever we count for when we do for this thing for when we using the table of 7, in you see 91, 91, 98, then 90, after 98 105. 105 is the first number after 100 which is divisible by 7, and the next number is 112, next number is whatever 119, and it goes on till which number, 196. I hope it should be 196. You can find out whichever is a number which is lower than 200 and that is divisible by 196. Oh sorry, divisible by 7. And these are the numbers which are divisible by 7. Let me check if this is hard. So these are the numbers which are divisible by 7 between 100 and 100 and 200. So how will you find how many numbers are there in this? You will use the formula for AP, that nth term is 196, first term is 105, and the common difference is 7. You can find the value of how many terms are there. I hope it is clear. How many terms are there? You could find which are divisible by 7. This part is clear. This is the you will do on your own. Second part, divisible by 9. After 9, after 100 and before 200, the last number is 100. First number is 108, which is divisible by 9. After that, the number is 117, I guess. Yes. And the last number, which is divisible by 9, should be 198. Is it? Am I right? 198. Yes. So again, you are going to use the formula for AP. You will going to find whatever the number of n is. Till this part is clear? You find all the numbers which are divisible by 7 between 100 and 200. And now, after that, there will be some numbers which will be divisible by, which are divisible by 9. You find that number. Now, third thing, there will be few common numbers which will be coming in this as well as this. Am I not right? So between this and this, there will be few common numbers. How will you find it? You find the LCM of 7 and 9, which is 9 7 is 63. So 63 is the first number between 100 and 0 and 100. Between 0 and 100, 63 is the first number which comes in the table of both 7 and 9. I hope it is clear. After that, 63 into 2, 63 into 2 will be 126. 126 will be the next number which will common to both 7 and 9. I hope it is clear. 63, 39, 189 is the third number which is common to both 7 and 9. So between 100 and 200, the common number between A and B, A intersection B will be two numbers. Those are 126 and 189. So you will get two numbers which are common to A and B. So all the numbers which are divisible now, I am going to use a formula for set theory. A union B is equal to A, which you will get from here, plus B, which you will get from here, minus A intersection B, which is 2, which we have already got here. You will find all the numbers which are divisible by 7 or 9. Right? 7 or 9. So whatever you value will get. Between 100 and 200, there are how many numbers? 101 numbers. Total 101 numbers are there. Out of that, you subtract this A union B. Whatever you value you get, that number is what? Those numbers are not divisible by either 7 or 9. So how did we start? They have asked which are not divisible. So rather than checking which are not divisible, what we did, we checked what are divisible. Once we found which are divisible by either 9 or 7, we subtracted that from 101 and you have got the answer. And how to segregate, how to only consider even numbers and odd numbers, that is totally on you. I'm not going to look into that. But if you want, from out of these numbers, how will you differentiate between even numbers and odd numbers? You have to do that half of those numbers are even, half of those are odd. You have to check on yourself, right? This is another level of difficulty, right? And also out of scope for CSET exams, this is a previous year CAT question, right? Even if you want to do out of curiosity, you can solve this even integers. How to segregate those from our answer, right? Now moving on. There are 3 clubs A, B, C in town. Which has these many members. While now there are, instead of 2 sets, we have 3 sets A, B, and C. So the complexity has increased. So do you need to learn all the formulas? No. Let's see how will you do this. There are 3 clubs A, B, and C in town with these many members. While 10 people are members of all 3 clubs. Members of all 3 clubs. But 70 people are members of only one club. How will you show this? So Venn diagram for in case of 3 is like this. This, and this. This portion is where the members are common in all 3 clubs. So how many members are there? There are total 10 people who are common in these clubs. Right? Now, how many members are there in A? That is 40. B has 50 and C has 60. Right? Now, 70 people are members of only one club. So if I consider this, so these people which are which are coloring as white, these people are only member of club A. If they are part of this, they will be member of A and B. No, we are only looking at those members right now which are member of only one club, this part or this part. So these are member of only one club, right? And the number of all such people is 70. Okay, fine. So now let's try to solve this question using just the basic equations. So all the members of A is equal to only A, means they are member of only A, this white portion, plus they could either be part of AB, plus they could either be AC, plus common in 3. This I am highlighting as C, oh, not C, let's highlight it as X. Means they are common in all 3. So how did I write this equation? So to write this equation, this complete circle, this complete A circle, this circle I'm marking right now, I will use another color. This circle has 4 parts. First part is which is only A. Second part is which is common between A and B. Third part is which is common between A and C. And fourth part is which is common between all the clubs. So A has these 4 components. Similarly, B has all these components. I did a mistake here. Not only B, but only A here. So B is only B plus AB plus BC plus common between all the clubs. C is equal to only C plus AC plus BC plus common between all those. How many belong to exactly 2 clubs? Exactly 2 clubs means they are asking for this part, this portion. I hope it is clear. Only they are asking for all those which are member of exactly 2 clubs. So let's try it. So adding all this part, you will get A plus B plus C is equal to only A plus only B plus only C plus 2 times. This part I am just writing it 2 times AB plus BC plus AC plus 3 times X. I hope it is clear. I am just added all those. So A plus B plus C is all the members of A, that is 40, plus all the members of B, that is 50, plus all the members of C, that is 60, is equal to, which are member of only one club. Which are member of only one club is 70 plus 2 times member of only 2 clubs, which exactly we are looking for. So that is our answer. So this is what we are looking for, which are member of only 2 clubs, plus 3 into 10. That is the common, right? So solve this. I am just noting it down. 60 plus 150 is equal to 70. 150 is equal to 70 plus 2 answer. Answer is whatever you are looking for plus 30. So 2 times answer is equal to 150 minus 100, that is 50. So answer is equal to 50 by 2, that is 25. This is what we are looking for. So this is a number of members which are part of only 2 clubs. Exactly 2 clubs. Not 1, not 3, but exactly 2 clubs. I hope it is clear. Difficult question. Again, I'm not picking from CSAT exams previous. These are the proper CAT questions, and this is going to up your level for the preparation. This question is done. Now we are moving to the last topic of algebra and also this video, that is sum of series. In arithmetic progression, we have already done sum of first natural numbers. So 1 plus 2 plus 3 plus 4. This is the first video of the revisions. So what sum will be n plus 1 by 2. We have already done this. We have already done a question on this. So don't worry, this is already covered. But just note it down. And if you want, you can go back and check arithmetic progression. From arithmetic progression only. If you want to derive this formula, this is arithmetic progression where first term is 1. Difference is 1. There are total n terms. You have to find Sn. Sn is equal to n by 2, 2a plus n minus 1 into d. You can solve this and you will get this formula n plus 1 by 2, and you have to remember this for the exam. Moving on to the second part. Sum of square of first natural number means you have to find 1 square plus 2 square plus 3 square plus 4 square and so on. So the formula for this is, note it down, n plus 1, 2n plus 1 by 6. This is the formula when we are looking at the square of first n natural numbers. n plus 1, 2n plus 1 by 6. I hope it is clear. Now, before attempting this question, I am going to write the formula for the third formula as well, that is cube. 2 cube plus 3 cube plus 4 cube and so on, right? So the formula for this is n square, n plus 1 square by 4. This is the formula. This is just a, if you want to remember this, this is just the square of the first formula we have learned like 2 slides back, right? This is done. Now we are going to see few questions on these three formulas. First one is already covered, arithmetic progression. I'm not going to do formula question on that again. Let's see the formula second, the square of the numbers. In this question, they are asking for, give me the answer for this 21 square plus 22 square plus 23 square up to 30 square. I know how to calculate the sum starting from 1. I know I can do this 1 square plus 2 square plus 3 square up to 30 square. I can do this. This is very simple. This is n plus 1, 2n plus 1 by 6. I will put 30, 31, 61 by 6 and this is the value. This is I could find easily. But I don't have a formula which can extract only this portion 21 to 30. So for that, what I'm going to do, this is the sum number 1. I'm going to take another sum. Sum number 2 is 1 square plus 2 square plus 3 square, but this time only up to 20 square. So the formula for this will be n plus 1, 2n plus 1 by 6 means n 20, 21, 41 by 6. This is S1, S2 is the sum of first square of first 20 natural numbers. S1 is sum of square of first 30 natural numbers. So the sum or the answer we are looking for is S1 minus S2. Means if I take all these terms, I'm using another pen. So if I out of all these, if I subtract till 20, I will get 21 square plus 22 square and so on. That is the answer we are looking for. So the answer we are looking for is from difference between sum of square of first 30 natural numbers minus sum of square of first 20 natural numbers, and that is what they have asked in the question. I hope this is okay. This is how you solve in the exams. Your mind should be ready for any type of question in the exam. You are ready with the formulas. Just the application part, you have to be smart how to use that formula you know by heart. Right? Now look at the last question. This question is 0.11 raised to power 3, 0.22 raised to power 3 up to 0.99 raised to power 3. Now, first thing, I know this much that I could do this one 1 cube plus 2 cube plus 3 cube up to n cube means I know this formula that n square n plus 1 by square by 4. But I have not read about 0.11, 0.22, 0.99. So for that you have to first be smart and try to make this equation into this. How will you do that? If I take 0.11 cube as common, so I will be left with 1 cube plus 2 cube plus 3 cube up to 9 cube. So this is 0.11 cube. Can I apply the formula for this? Yes. And the formula is n square, that is 9 square. 10 square means n plus 1 square divided by 4. So the answer I am going to get from this is the answer I am looking for. Right? So you have to know the three formulas. First n natural numbers, square of first n natural numbers and cube of first natural. But that is not sufficient. The question they have asked is you have to first try to see how you are going to apply the formula you know. Right? And that's all for the algebra section. We have already covered whole algebra in 3 videos. This is a revision course right now we are going with. And if you want to download this PPT, you can download it from our Telegram channel. And the other thing is, if you have any doubt, please feel free to post them in the comments. So here today we have, just a quick revision of algebra. We have already done with progressions. We have done arithmetic progression, geometric progression and harmonic progression. Then what we did? We did equations, we did linear, we did quadratic and we did cubic. Today we have learned 3 miscellaneous topics, that is logarithm. Second topic was, this third topic was sum of series. The second topic was, even I got confused, second topic was set theory. Yes, set theory. Set theory. So if you ask me which one is more important, this is the most important topic. One of the most important topic is algebra. If you consider all the 9 topics, I would say the set theory is surely among top one or two. Lot of questions are asked from set theory. Then you could say that this APGP will be important. Then linear and quadratic will be important. Cubic, they don't ask a lot of questions. Logarithm, they don't ask lots of questions. Sum of series, for sure, this is also very important. I hope this is clear. Our algebra part is done. After this, we are going to do arithmetic section. That we are also going to try to complete that in three, 4 videos. Once that is done, then we will move to number system, and that is done. We'll try in the last leg of our preparation. We are going to solve as many questions from previous year or CAT section just for your revision. Now you know once these topics are clear to you, you don't have to invest your time in each and everything. You don't have to read all the questions or all the topics. Just strengthen your topics which are like the major topics, and the irrelevant or the I would say low priority topics. Now don't invest a lot of time on them, right? So this completes our topic for algebra. See you in the next video. We'll be starting with arithmetic soon. Thank you and best of luck.